All right, welcome to our first set of notes on this one. Obviously we've had our break here, but let's get back into where we were. We started off and left off with the Paleozoic Era, which was the old animal life. So now we're going to go to the middle animal life, or the Mesozoic Era. That's going to run from 252 to 66 million years ago, so we're getting right up closer to where we are today. This is one of the larger areas, and one of the things we're more familiar with because we think of all the famous animals we're used to dealing with here. It's broken into 3 periods. The first period is the Triassic Period. The Triassic Period runs from 252 to 201 million years ago. Well, Pangea, we spent a lot of time getting up to the point from all the different supercontinents to get to Pangea during the Permian. Now it breaks up. It's going to break up into a couple supercontinents. One we're familiar with, our favorite, Gondwana. But it's also going to come up with a different one that we're sort of using some of the names we had before. Laurasia. Laurasia now has Asia because it's going to come up out of the ocean. It's going to be attached to Europe, and you're going to have North America attached to it as well. So it's going to be a very large, sort of northern and southern continents. But if you have a north-south group of continents, between them, you have an ocean. In this case, a place called the Tethys Sea. Tethys Sea is a very famous place because there's still parts of it left today. Part of it is things like the Mediterranean Sea, the Indian Ocean, and another part that we wouldn't think of as because it's not underwater anymore, which is the northern part of Africa, the Sahara Desert. That's why they find a lot of fossils in the middle of the Sahara Desert of oceanic creatures, because that area at the time was the bottom of the Tethys Sea. As the continents moved, eventually gets shoved up out of the ground, up out of the water, and thus creates dry land. So you see the world time period. See, the continents are still roughly connected, but they're starting to move apart from each other. You have your north-south split. You're going to split right across here with the Tethys Sea running across there. North America is going to be right here. You're going to see now we are no longer under the ocean or near the edge of the ocean. It's been shoved away from us. So we are smack onto dry land right now. Big key thing here is the first dinosaurs show up. They're not your big, giant dinosaurs you think of like T-Rex or the big, long-necked dinosaurs or the hadrosaurs or things like that, or Triceratops. They're going to be small little dinosaurs. Things that are going to run around maybe a foot tall, maybe 2 foot tall. If you saw the Jurassic Park movies, the second one, all those little dinosaurs that attacked the guy after it kicked one of them, they're from this time frame. There are still giant reptiles around of other groups, and they're still existing that have survived past the Great Dying at the end of the Permian. But they're going to die off because there's going to be a mass extinction. When you move all these continents around, you can think what's going to happen. You're going to change all the climates quite a bit. And so you're going to get all those other things dying off. That's a benefit to the dinosaurs because now they go from being small little guys to start to fill all the different roles in the environment. Then we get to Jurassic Period. Jurassic Period goes from 201 to 145 million years ago. Most people know it because of the movie Jurassic Park. The key here is the first flowering plants show up. They're not the dominant group. They just show up at the first time. Later on, they're going to become the dominant group as they are today. So things like grass will show up later, not in this time period, but in the next time period. The first mammals and birds show up. Now, the fossils of these being found in China right now are actually starting to push this date back into the Triassic. But you're finding things like little small mammals, little small birds. Everything's going to be very tiny for the most part, about the size of a medium-sized dog for the mammals. Dinosaurs become the dominant land animals. You get your big long-necked dinosaurs. You get your hadrosaurs. You get a lot of the things we're familiar with. You get big pterosaurs. You get all those kind of things like that. T-Rex originally was thought to just be Cretaceous, but now we realize that the earliest T-Rexes show up at the end of this time period, so they do show up in this time period. But other big, large carnivores are much more prevalent prior to them, just not as big as them. The Atlantic Ocean starts to form. So as you split apart the northern and southern continents, that all of a sudden Gondwana splitting, Laurasia splitting, you're getting a split between them. You're creating an Atlantic Ocean. So you see right here, it's going to be forming through between Africa and South America and North America and Europe. So what's going to happen when you do that is you're pushing the plate. So the North American plate gets shoved. So out here in the west coast, a landmass pushes up, forming a mountain range. But it pushes down the center here, causing a big inland sea. That inland sea eventually is cut off, forms a large inland lake called Lake Bonneville, which today is left over as the Great Salt Lake. But there's also a place called Bonneville Salt Flats, which was where a large flat area where they raced cars in order to test them, because it's a large flat area that's just naturally flat. It's formed by the bottom of that ancient ocean. The Cretaceous period, the third final part of the Mesozoic. It runs from 145 to 66 million years ago, or 65, depends upon how people argue about it. Most oil reserves from this time period, so the animals and plants that lived this time period, as they died, and under different conditions, their bodies were pressed by over time underground and eventually formed into oil, the oil we use today. Rocky Mountains are formed. As we saw those continents moving, that Rocky Mountains being pushed up. It's also occurring in South America as it's being pushed, or creating the Andes. Flying plants become the dominant group. They went from quickly being something you showed up, to all of a sudden now they're the dominant group, and they stay the dominant group. We know there's mass extinction at the end of this, because obviously the dinosaurs end up dying off at this time period. What caused it? There's all kinds of theories. The most common theory, the most common belief, understanding is probably a meteorite or a comet hitting the Earth. And then the other common theories are things, the fact that, well, since all these continents are moving, climate change may have killed off the dinosaurs as well. They're starting to die off before all this happened. Some people say it's a mixture of both. Some say it's a lot of things. The mass extinction, a lot of people argue for a long time, where did it, if you had a comet hit, where did it hit? Well, it took a long time. They finally found the spot, a place called the Chicxulub impact event. Chicxulub occurs in the Yucatan Peninsula, and they discovered it while they were doing mineral studies looking for oil. We refer to that time frame, this 65 million years ago, as the KPG boundary. K for Latin verse for Cretaceous, and PG for Paleogene for the next period. It's marked by a big concept, a big mystery basically. Around the Earth, they found a layer of a rare mineral called iridium, which is primarily found just from space, usually from meteorite impacts, but it's found in a thick layer all the way around the Earth. So all around the Earth, you have a layer at the same time frame, and when they dated it, it came out the exact same time frame, about 65 million years ago. That's one reason why we understand there's probably an impact event. People ask, how can one impact event kill off the dinosaurs? Well, it causes a nuclear winter, basically. It closes out the sunlight, keeps it from happening from all the dust in the atmosphere. The estimates were that the meteorite would have been the size of basically a small mountain. And that's what would hit the Earth in that area, causing immediate death for everybody in general vicinity, but then also long-term deaths. And the only thing that survived were smaller animals that could hide better and do things like that, like mammals and birds. So that's part of the concept of the theory of this. By the end of this time period, the Earth looks much closer to what we're thinking today. Not quite, but it's getting there. We see Antarctica towards the southern part where it's supposed to be. But you also notice it's still connected to Australia and South America. That's because after this time period, it's still not covered in ice. You're going to have animals traveling back and forth. That's why marsupials are found native on these areas originally. You're going to find them in Australia, in fossils in Antarctica, and you find current living ones still in South America, because they were able to go back and forth after this time period, the early primitive marsupials. You can see over the three periods how it's changed. The different periods have shown more and more growth of things, and over time how the different continents went from Pangea all the way to looking closer to what we have modern continents.